Good morning. Welcome back. I thought it might be helpful if I walked through one of these problems with you. So I picked problem number 2 for analyzing the graph of the derivative. And the reason I did that was because I think it involves FTC2. And I know that sometimes freaks students out. So I thought, let's just do that one. And what I would suggest is maybe like stop the video and try number 1 and then play the video and see if you got it. Okay, so I'm going to go ahead and do number 1. Let's go up here. So it's asking us to find g of 3. So g of 3, and I'm just going to then plug in 3 for x. So now we have the integral from 0 to 3 f of t dt. And this means the area, right, from 0 to 3. So we're going to look over at the graph here, 0 to 3. Well, we have 2 pieces here. We've got this quarter circle, and the area of a quarter circle is pi r squared, right, is the area of a whole circle, and then we're going to divide it by 4. Yep. And then we're going to go from 2 to 3, which is a negative area, right? So I'm going to say minus 1/2 base times height. Okay, now we just have to figure out, okay, what's our r? Well, that's easy. Yeah, you said it. It was 2. So pi times 2 squared over 4 minus 1/2. The base of our triangle here is 1 from 2 to 3, right? And the height is 1 also, or negative 1. But that I already put the negative out here, so I don't want to double negative it there. So that's a big mistake right there. Okay, and so then we just get 4 divided by 4. Well, that goes away, and we just left with pi minus 1/2, and we can just keep it like that. I know it looks weird, but that's it. That's g of 3. All right. Okay, let's go ahead and fold that over, and now let's do the next part. Okay, now it says, for what values does g have a relative minimum? So what we're going to do here, number 2, for finding relative maximum, excuse me, relative max. What do we always do to find maxes and mins? You said it. Take the derivative, set it equal to 0, right? So we're going to take the derivative, find those critical values, right? And here, when we take the derivative, this looks a little bit strange, right? You're thinking FTC2, right? FTC2. All right, which means we cross this out, the derivative and the integral cancel out, and we plug in x. So g prime is equal to f of x, and we've got the graph of f, which means we also have the graph of g prime. Yes. So let's go ahead and go over here, and we're going to make a quick sign chart to find our relative maxes and mins here. Okay, so g prime gives us the behavior of g. And it looks like we have a 0 here at negative 2. We have another 0 at 2. And we have a 0 at 4. Okay, and the sign of g prime here is positive, positive. Between negative 2 and 4, it goes down below the x-axis, so then it's negative and then positive again. So we're increasing, increasing, decreasing, and Lord. Owen, get it right. Increasing, right? Okay, there we go. So now we know if we're increasing and increasing, but we have a 0. Oh, wait a second. We don't know what's going on, do we? So I'm gonna cross this out. We don't know what's going on prior to negative 2. I shouldn't have put a positive there. Okay, so we don't know what's happening at -2, but at 2, we do. We're increasing up and then we're decreasing, so we have a local max. Yep, and then at 4, we have a local min. So we've got everything now that we need to be able to answer this question over here. So for what values does x have a relative maximum and why? So we need to justify our answer. So g of x has local or relative max at x equals 2 because g prime changes from positive to negative. So that's for 2. Number 3, for what values does g have a minimum and why? G of x has, can you guys see that? Yep, local min at x equals 4 because g prime changes from negative to positive. Okay, now part 4. What do they have in store for us? For what values of x does g have an inflection point? Okay, so inflection points, now go to your flashcards, right? And you said inflection points, you have to do absolutely, the second derivative. So when you're looking at the graph here of g prime, this is the, I'm going to put this in pink, the value of the graph, right? The value of the graph. So here we're positive, negative, positive. Now we want g double prime. We're going to look at the, yeah, I know you said it, slope. So now this is the slope of the graph. So now we're looking every place where the slope is d on e or 0. So here at 0, so right in between here, 0, the slope is 0. And it looks like the slope changes there, doesn't it? It's kind of weird at 2. I'm going to list that because I don't know what that is, okay? And then also at 3, it's definitely changing, right? So here this is positive slope and then a negative slope. This is also negative, but it does have a little kink in it right there, right? So I'm going to put D on E right there. And then here it changes from a negative slope up to a positive slope. Okay, so here we're concave up, concave down, concave down, concave up. So we do have an inflection point where concavity changes. Inflection point, PI or IP, however you want to say that. Okay, so now we just list those. We get all of our answers from that second derivative sign chart. Here we go. G of x has inflection points at x equals 0 and 3 because G double prime changes sign. And we don't care if it changes from positive, negative, or negative to positive, no matter. Okay, and then finally, number 5, our last question here. Can you see it? Okay, number 5. Write an equation for the line tangent to the graph of G at x equals 3. Okay, what do we need for an equation of a line? Yes, you said it. I know you did. Point and slope. And then we can write our equation. Okay, so let's go back to x equals 3. We know G of 3 is equal to, I know it looks totally weird, right? Remember, we have to go back up here. Our G of 3 was pi minus 1/2. Weird. Okay. And then our slope, G prime at 3. Let's go look. Uh-oh. G prime of 3. Wait. Oh, it's the value of the graph. I was having a problem there because I was thinking it was the slope. That's double prime, right? Okay, we're looking for the value of the graph at g prime of 3 is -1. Yes, you got it. Okay, now we can write our equation. Y minus, and I know it looks weird, pi minus 1/2 is equal to -1 x minus 3. And you are done. Thanks, guys.